Hi everyone. So today I'm Stephin here. So our seminar is based on distributed databases and semi-structured data. So today I'll be taking on the topic like distributed database systems, covering distributed query processing, transparency features, advanced indexing techniques, and semi-structured data formats such as XML and JSON. So these are the fundamental for like modern large scale systems like cloud platforms and telecom systems, banking environments, and IoT networks such like that. So as we all know, what is a distributed database? So it is a storage, like a distributed database is storage, storing the data into multiple places. So the data is not stored in a single place but into multiple. The data is physically spread across multiple computers or like locations, but the user experiences this as like a single unified system. Whenever the user sees, it seems like it is coming from one system only. But in the backend, it's what happening is like it's divided into multiple locations. So what's the purpose of distributed databases? So it has reliability and higher availability, fast access through local copies. So these are the main features of distributed databases. So today we'll look into at how queries run across distributed nodes, how system hides complexity from the users, what the indexing methods are, like how this helps in the whole query processing and all. So, so speaking of distributed query processing, so when a query is executed in a distributed environment, the system must decide where the required data is located. How should the operation be split across sites, or how can we minimize the communication cost? So, in distributed query processing, manages these decisions automatically. So, to achieve this, the process involves three main steps like query decomposition, data localization, and query optimization. These are the main three steps, and finally is like the query execution or like getting the results. So first, we are going into query decomposition. So what happens in this phase is like SQL query is transformed into like internal representation like a relational algebra. So the system breaks the query into smaller parts, like smaller logical components, like selections, projections, joins, etc. So it also perform checks such as like queries correctness, eliminating redundant conditions, like and simplifying the expressions. So this is a primary step happening here. Like this step is about understanding the query and converting it into the suitable format for the distributed execution. So the second thing is like data localization. What happens in this localization? So once the logical query plan is built, the system identifies where each required piece of data physically exists. So because data may be horizontally or vertically fragmented or even replicated, the system maps operations into physical locations. For example, like if a custom data is on site A, let's say that it's on site A, and the orders are in site B. The system must plan how the join between these are executed. Like how can we join these? So what our aim is here, like avoid moving large data sets unnecessarily. So because the communication cost will be high if we are moving all these into like all this data, so we must avoid those. Like we don't need to bring all the data into our all the data, getting only the whatever we need. So our main aim is like avoiding moving large data sets unnecessarily, so in order to like reduce the communication cost and all. So the third step is like distributed query optimization. So this is the most and important part. Like the main goal is like reducing the communication cost. So query optimization, what does query optimization does? Like selecting the best execution plan. That's the happening optimization. So there are certain factors that are like considered for like getting the best optimization, like a best factor. So there are like minimum amount of data transfer must be there, like fewer remote calls must be there, maybe selecting the efficient join strategies, maybe semi join like that, maybe pushing filtering operations to local sites before shipping data. So before like sending the data, filter out whatever we have, we do need. That's it. So the major technique we use here is like semi joins. So instead of sending the entire tables between sites, only the necessary join attributes are transferred first to reduce the result set. So after this step, we are getting the result. So in our results, we only need what's important to us. We don't need to bring all the data. So we use semi joins like that. So what's the purpose of query optimization is like improving the cost, like cost efficiency, improving the cost efficiency. And last is like the execution of this execution phase, which is the last phase. So each site executes its assigned operational in parallel. Maybe like the so we get the final data. So next is like we are talking about the transparency in distributed databases. What is transparency means? So what transparency means is like being transparent. That's it. Like hiding the complexity of this underlying distribution from the user. Ideally, like the user should not know how the data is split, like where it is stored, or like whether replication is exists. So the user doesn't like need to know all the things that are happening in the backend. So we use transparency, which means when the user looks, it should be clean and efficient. So in order to do that, we use transparency. So this makes the distributed systems much easier to use and develop applications. So there are certain types of transparency. So we are getting into that. So first is like fragmentation transparency. What is this fragmentation transparency means? So fragmentation transparency hides the fact that a table may be divided into fragments located at the different sites. A simple example is like um, customer. Records begins with A to M, maybe stored in a site A. Maybe and customer records from like alphabets N to Z are maybe in site 2. So these are like stored in a different locations. That's called fragments into different sites. Those are the fragments. So users still query the table as if it were like in a single entity. The user doesn't know it's coming from two different things. The user sees it as like one. The system automatically gathers data from all these fragments. This improves the performance and allows parallel processing. Okay, that's it. And next is like replication transparency. What is replication transparency means? So replication maintains multiple copies of the same data across sites for reliability and load balancing. So copies are stored into different sites. So replication transparency ensures that the user doesn't need to know how many copies exist or where they are stored. So main advantages is like improving the fault tolerance, maybe faster reading performance, high availability. Even if one node fails, like maybe one node fails, we still have the data in that other nodes. So availability of the data. So these are like for replication transparency. That then comes the location transparency. What does a location transparency means is like that user doesn't need to know the physical storage site of the table or record. For example, like a query like select staff from employees works anywhere, whether actually the data is in site A or site B. The employees table, maybe the data is into different tables. There are like different tables, but that doesn't need to know. Like it doesn't matter where the data lives, where the data is stored. uh, it's simply for like the greatest it simplifies applications development and maintenance by completely decoupling the logic and physical data and placement. That's it. That's happening this location transparency. So the location wherever the data is stored, the locations are not shown. That's it. And we are getting into indexing methods. So there are some next topic. We are moving into the next topics like indexing. What is indexing? There are like set and bloom filters, bitmap indexing, arc trace like special indexing, hash based indexing. Getting into these. What are these? So, large scale and distributed system needs more efficient indexing structures than there are traditional B trees. So, we use the for advanced indexing methods like Bloom filters, bitmaps, arc trees, and hash base. So, what do these do? Like these help in speeding up the queries in high volume, specialized environments like big data warehouses and spatial systems. So first we are going into bloom filters. So what is a bloom filter? Bloom filter is a space efficient data structure used to test whether like an element is a member of a set. So that's what happening in this bloom filters. It may return false positive but never false negatives. You understand? Like this means like if the filter says not present, it is guaranteed true. Like the filter says like this is not present, so which means that it's true. Like these are used in like distributed joins, like avoiding to avoid sending unnecessary rows, maybe caching systems, maybe networking loops like HDFS and Cassandra, NoSQL databases to reduce the disk lookups and all. So what do Bloom filters do is like they reduce the expensive disk input output and avoid transmitting unnecessary data between distributed nodes. And next is like bitmap indexing. So what does a bitmap index do? Bitmap index like represent each distinct value of an attribute as a bitmap, like a long array of bits, like in a rows containing the values like bit is set to 1 or otherwise 0 1 or 0 like that. So these are like used for uh, heavy environments where low cardinality columns like gender, maybe as you can gender like male or female like that, or maybe pass or fail like that, maybe flag values like we can say it's flag values. And next is like maybe in data warehouses and all. So the biggest advantages of these operations are like and or not can be performed fastly using bitmap indexing. So that's what bitmap indexing is for. Like as you can see in this example, we can differentiate between fail or pass. We just assign this pass as like if one person is failed, that column is can will the bit value will be set to 1. Wherever the person is passed, that it will be set to 1 like that. So that's what happening here. So moving on to next, we are going to R trees, spatial indexing. So R trees are like multi-dimensional indexing structure, but these are used for like spatial geometry data. Like instead of indexing single values, they index shapes like regions, coordinates and location like that. So an RT groups are groups nearby objects using boundary rectangles. This allows like fast lookups for queries like maybe suppose we all use like Google Maps and all, like, so finding all the restaurants near this location. So it's basically like a groups all those data that are in a cluster. So maybe like another example is like retrieving all the vehicles in a geographic region. So that's what happening in arteries. So arteries are like massively extensively used in Google Maps, like IoT sensors and spatial search engines and all. So that's what happening. Arteries or spatial indexing. And next, we are moving into hash-based indexes. So, what is hash-based indexing is like? It uses a hash functions to compute a bucket for each key. So there is a hash function is there. There is a hash function is there to to compute like for each key. These use there will be a key and there will be a hash table. So it's like key value pairs. So key value are stored. How this is stored is like key value stores. So a hash uses a hash functions to compute a bucket for each key. These are like efficient in for like equality based searches. Equality based searches is giving like almost constant time, like order of one lookups like that. So basically, these are also used in like NoSQL databases like that. So hash indexes are not used in range queries, but uh, they are like more good at like distributed environments requiring fast key exchanges. Key exchanges, key access are needed. So that's it for like hash-based indexes. Okay, like as we are moving into the semi-structured data, what is like structured data and semi-structured data? We all know like structures data like they have a proper structure. The data is stored into like rows, columns, and all. But semi-structured data, the data this is like it is semi-structured. So mainly the common formats are like XML, JSON. So these are like having very good like benefits. A lot of benefits are having for this semi-structured data. So going into semi-structured data, what is does a semi-structured data means? It's like it doesn't have a rigid schema or like a strict and predefined schema uh, like the relation databases. It is more flexible, like maybe of having self-describing structures. So basically, examples are like XML, JSON, sensor logs are there, like API responses are there, configuration files are there. So their flexibility, like it makes ideal for like environments where data varies frequently. That's the main part. Like wherever the data varies frequently, these are very useful. Okay, uh, so first we are going into XML. What is it like XML as a semi-structured data? So XML means like extensible markup language. So this is represented data in structured hierarchical form using tags. Tags are used. Yeah, this supports nested elements, attributes, and complex relationship. Like some benefits of using this XML is like these are like more human readable and also machine readable. Like these are like strictly structured. Maybe these validations are using like DTDs or like XSDs. Like these are like ideal for document based and enterprise level data integration XMLs. So and also these are like good for using in a long term storage due to self descriptive nature. So XMLs are basically used in web services and configuration files in software systems, scientific data interchange, and also like cross-platform and price data sharing. So like and also XML is like more heavier, like heavier and but they are like the more heavier they is like more powerful. And next is like JSON. Talking about JSON is like second thing we are going into is like JSON as a semi-structured data. So the JSON, the full form of JSON is like JavaScript object notation, which is like lightweight, which is flexible and widely used in like interchange format. So JSONs are like more easier to read, write, or pass compared to XMLs. So what are the advantages of this JSON files? Are like these are like they uses like simply key value pairs, and also like JSONs are like supported by JavaScript and one of the modern languages, and these are like compact and efficient. JSONs are compact and efficient, and the main application is like for API calling. So API communication, most probably in every situation, JSONs are used like REST APIs, and also in mobile and web applications where real-time IoT devices are used, like NoSQL databases like MongoDB. All this uses JSON files. So what makes JSON this much popular is like this is simplicity. Is why it becomes a modern standard for like data exchange. So we are moving into the like applications of semi-structured data. What are the main applications of semi-structured data? So semi-structured data formats are dominant in modern digital systems due to their flexibility and ease of integration. So these are like mainly used in web applications. In almost every web applications, web APIs use data like JSON, as I said. And second, it's like and IoT systems they are used like maybe this sense the data in flexible lightweight format like JSON, like in IoT maybe in what happens is IoT senses like the data changes every time. The data change happens every single time, maybe within seconds and all. So this, JSONs are used. These are like lightweight formats. So these are used. Also, another application is like in big data pipelines. They are used like logs collected from servers, applications, devices. All these things are like formatted in a semi-structured data, and these are used in social media platforms like user-generated posts, comments, metadata. So these do not follow a fixed schema. So most of them are like stored in a semi-structured data, and like they are also used in cloud platforms, services like AWS, Azure, Google Cloud Data Exchange using JSONs and YAMLs. OMLs. As data engineer, like I mostly use like JSONs all the time. So I've used AWS, so JSONs are like mostly used in all these logs and everything. So what makes this semi-structured data more useful is like the flexibility, like which helps in organization to adapt faster and to changing data requirements without altering their rigid schemas. Okay, that's that. So we are getting into the conclusion like what all we have just gone through. So we have gone through like distribution query processing to ensure that efficient execution across multiple sites, transparency hides that complexity of distribution, and also like advanced indexing accelerates that data retrieval in large scale systems. And also last we talked about the semi-structured formats for the flexible data handling across the modern platforms. So these are the things. Thank you.